Our question is 250 ml of a waste solution obtained from the workshop of a goldsmith contains 0.1 molar AgNO3 and zero point 0.1 molar AuCl. The solution was electrolyzed at 2 volt by passing current of 1 ampere for 15 minutes. The metal or metals electrode deposited will be only gold, silver and gold in proportion to their atomic weights, only silver, silver and gold in equal mass proportion. We are given the reduction potential for silver is 0.80 volt and reduction potential for gold is 1.69 volt. Okay, since in this question we are passing the voltage of 2 volt, so both the silver and gold will get reduced as the reduction potential is way lower than 2 volt. Secondly, we'll be solving this equation based upon the Faraday's second law. So let's see our solution. As the voltage is 2 volt, so both Au plus and Ag plus will reduce and their equal gram equivalents will also form. Gram equivalents of gold will be equal to the gram equivalent of silver. Now, the formula of gram equivalent of gold and silver is that we know that gram equivalent is basically the weight of any substance divided by its equivalent weight. So, it will become weight of Ag divided by equivalent weight of Ag is equals to weight of Au divided by equivalent weight of Au. On rearranging, we get weight of Ag divided by weight of Au is equals to equivalent weight of Ag divided by equivalent weight of Au. Now, we know that equivalent is basically obtained by dividing the atomic mass of any substance by the valency. Both Ag and Au we can see form plus 1 ion, right? So the equivalent weight formula will be atomic mass of Ag divided by 1, equivalent mass of Au divided by 1. So weight of Ag upon Au will become equal to atomic weight of Ag divided by atomic weight of Au. That means the amount of silver and gold deposited will be in equal mass proportion. So our option second is going to be correct answer here.